Hi everyone. In previous classes, we have already learned that the various types of errors that happened during the measurement. And in this class, we are going to describe the combination of errors. If we do an experiment, it involves several measurements, and we must know how the errors, all the measurements combine. Here we are going to explain 2-3 methods of combining the errors during the measurement. The first one, errors of a sum or a difference. Suppose two physical quantities A and B are measured, and the measurement of the physical quantity A is A plus some error happened there, and that is delta A, and that error can be plus or minus. And for B, the error will be B plus or minus delta B, where this delta A and delta B are the absolute errors. If we want to find out the error in delta Z is the error in this measurements, we can find out the sum of the errors first. For example, Z is the resultant quantity, okay, and Z is equal to A plus B, okay, and A is the physical quantity and B is the another physical quantity. We have by addition, if Z is the result quantity, sum of this physical quantity A and B, Z is the resulting quantity, and if there is an error in this measurement, and this resultant quantity can be written as delta Z plus delta Z, okay, that will be A plus B can be written as A plus or minus delta A plus again B plus or minus delta B. So here the error, the absolute error in this both quantity plus or minus, then what will be the maximum error? The maximum error will be plus delta A and plus delta B, and the minimum error will be minus delta A and minus delta B. So if you want to find out the maximum value of the absolute error, then we can write the maximum value of error delta Z is equal to, what it will be, delta A plus delta B. That will be the maximum error in the delta Z. And this is for the sum. And for difference, we can write Z is equal to A minus B. Z is equal to A minus B. So we can write A minus can be written as Z plus or minus delta Z is equal to A plus or minus delta A minus B plus or minus delta B, and that is equal to A minus B. A minus B will be taken A minus B. And what is remaining? Delta plus or minus delta A plus or minus delta B. So that is equal to, again, the absolute error that can happen in this, the difference of a measurement, then that will be delta Z is equal to plus or minus delta A plus or minus delta B. Then the maximum possible value for the absolute error that can be delta Z is equal to delta A plus delta B will be the maximum possible value for an absolute error. Hence, the rule is when two different quantities are added or subtracted, the absolute error in the final measurement is the sum of the absolute errors in the individual quantities. Next, error of a product or a quotient. Here suppose Z is equal to A into B, the product of the physical quantities measured here. And as we already know, A is equal to A plus or minus delta A and B is equal to B plus or minus delta B. And we substitute the value here. So the resultant error will be Z plus delta Z. So that will be plus or minus delta Z. That is equal to, instead of A, we can write A plus or minus delta A into B plus or minus delta B. And now we are going to multiply these terms together. So what we will get? A into B, AB, then plus or minus, then delta A into B, that is B into delta A, plus or minus. Now A into delta B plus or minus delta A into delta B. Divide this LHS by Z. Okay. Divide LHS by Z and RHS by AB. So what will happen? Divide here Z plus or minus delta Z divided by Z is equal to AB plus or minus B into delta A plus or minus A into delta B plus or minus delta A into delta B. This term divided by AB. Now what will happen? This Z and Z will be cancelled. Okay. So Z divided by Z, that will be 1. Okay. Then what will remain then? Delta Z divided by Z. Delta Z divided by Z is equal to, then AB divided by AB will be cancelled. Okay, that is will be 1. Then that is equal to, then what will remain here in the first time? B into delta A divided by AB. So B and B will be cancelled. Then what will remain? Delta A divided by A plus or minus, then plus or minus this term A into delta B. Okay, here A and A will be cancelled, that will be 1. Then delta B divided by B plus or minus, then delta A into delta B divided by AB. Since the product of the absolute errors here, delta A into delta B, is very small, therefore we neglect this term. So what will remain there? Delta Z divided by delta divided by Z is equal to plus or minus delta A divided by A plus or minus delta B divided by B will be the absolute error in this, the product of these two quantities. This is the maximum relative error of this measurement of these two physical quantities A and B. When two quantities are multiplied or divided. The relative error in the result is the sum of the relative error in the multipliers. The same way we can prove this, the relative error in the quotient, and that is your home assignment. Error in case of a measured quantity raised to the power. Suppose the result quantity z is equal to a square, and this a square can be written as a into a. That is, now this is the product form, a product of a measured quantity. And how we can write this? That is, a can be written as a plus or minus delta a, and a can be written as a plus or minus delta a. For the two products we have already proved, and so directly we can write what it could be. That will be plus or minus delta a divided by a plus or minus delta a divided by a. That will be the maximum relative error in this product, right? So that is equal to what? 2 delta a divided by a. So hence the relative error in this product of a measured quantity, and if the measured quantity is raised to the power of 2, then it will be 2 times the quantity. That means if the quantity is raised to the power of 3, then 3 times the relative error in that quantity. If it is raised to the power of 5, then 5 times the relative error in that measured quantity. In general, we can write, if a quantity is raised to the power z is equal to a raised to the power of p and b raised to the power of q divided by c raised to the power of r, then how we can expand this? And directly we can write it is p times delta a divided by a plus b raised to the power of q. That means q times delta b divided by b plus, and divided by c raised to the power of r. That means r times delta c divided by c. Hence the rule is, the relative error in a physical quantity raised to the power of n is the n times the relative error in that measured quantity. These are the 3 kinds of combination of errors in a measured quantity. I hope you understand.